So in this section, we're talking about trig derivatives. Kind of mercifully, the videos are pretty short, right? I mean, there's not that much information compared to some of the previous sections. We're really just taking stuff that we learned in previous sections and seeing how that implies a few different derivatives, which I'd encourage you to memorize these 4 new derivatives here. And then if you have these memorized, it's not that hard to do some examples involving those things. The work ends up being stuff you learned in previous sections, stuff like the coefficient rule and the product rule and so forth, more so than applying these different derivatives. I mean, admittedly, these derivatives are a little bit different. Derivatives being something times something or something squared might feel a little foreign to you. But once you get beyond that, arguably the biggest challenge of this whole section is just memorizing these 4 facts right here. We did some examples in the last video of typical problems in this section, but there's one more thing that I want to talk about. So far, all we've done is take derivatives, but we haven't really tied that back with what a derivative means. What a derivative tells you is the rate of change of a function. And that can answer some really interesting word problems and applications, but all of that is happening later on in the class. But one application that we do know so far are tying the derivatives back to the slopes of tangent lines. The very first time we talked about the word derivative, back in like the first week of this class, we said it's the slope of the tangent line. So for example, if I had a function like f of x equals tangent of x, which is what's pictured here, I could ask you about the tangent line to this function at a given point. X equals pi over 6 apparently. So here's pi over 6 right here. I could sketch the tangent line to this curve at this point. Sketching tangent lines is always a bit of an approximation, but I don't know, the line in green appears to be about what we're talking about. This is more or less the tangent line to this curve f of x equals tangent of x at this point. When we figure out the derivative of tangent of x, we're coming up with a function that tells us the slope of the tangent line to this curve at any point, not just at pi over 6. And then once we know the slope of the tangent line to this curve at any point, we can figure out the slope of the tangent line at some specific point by just plugging it in pi's over 6's. Once we figure out the slope of the tangent line, there's no reason we can't figure out the equation of the tangent line, and that is what we're going to try to do in this example. Find the equation of the tangent line to this function f of x equals tangent of x when x equals pi over 6. You don't need a graph to do this at all, but I wanted to give you the graph for the visual learner to kind of tie this all back together. So I got f of x equals tangent of x. My first step is let's figure out f prime of x. F prime of x, fortunately, is pretty straightforward. I mean, you could figure it out by changing tangent into sine over cosine and do the big long derivation, or maybe I should say medium long derivation that we did in the first video here. Or you could just have memorized that the derivative of tangent is secant squared. So if f of x equals tangent of x, f prime of x equals secant squared x. But I don't want f prime of x. I don't want a formula that tells me the slope of the tangent line at x. I want to know what the tangent line is when x is equal to pi over 6. So really what I'm trying to figure out, the slope of this line, maybe we can call it m, is what is f prime of pi over 6. Well, fortunately, once you know f prime of x, f prime of pi over 6 is pretty easy. All you got to do is change all the x's into pi over 6's. So f prime of pi over 6 is whatever secant squared of pi over 6 is equal to. You probably don't have memorized what secant squared of pi over 6 is equal to. But what you could do is you could rewrite this as the secant of pi over 6 squared. And then you're like, okay, that seems a little bit more manageable, but I don't have memorized what secant of pi over 6 is equal to. I'm like, don't worry, I got you. Secant is the same as 1 over cosine of x. Therefore, secant of pi over 6 is the same as 1 over cosine of pi over 6. Therefore, secant of pi over 6 squared is the same as 1 over cosine of pi over 6 squared. And maybe this is something that you can evaluate. You're like, nope, sure can't. Don't remember cosine of pi over 6. Okay, that's fair. But I bet at some point you did know cosine of pi over 6. I bet at some point you knew how to draw the angle pi over 6 in the standard position and understood that the x-coordinate on the unit circle at this terminal point defines the cosine, and maybe even had memorized that the x-coordinate here is root 3 over 2. The y-coordinate's 1/2, but that's not really relevant here. What I'm saying is instead of writing cosine of pi over 6, I could write root 3 over 2. So I have 1 divided by the square root of 3 over 2 squared. Ooh, fractions inside fractions. That's really ugly. Yeah, but if you recently took a trig class, maybe that doesn't intimidate you too much. Maybe you could think about this as 1 over 1 and divide these fractions by multiplying by the reciprocal. And what you'll end up with is 1 over 1 times 2 divided by the square root of 3, the reciprocal of the denominator here. And then that needs to be squared. It's tempting to look at the 2 over root 3 and be like, ooh, and I need to rationalize. And I'd be like, no, you don't, because you're squaring out here. And when you're squaring a fraction, that's the same as squaring the top and squaring the bottom. So this is 2 squared, aka 4, divided by root 3 squared, aka 3. What I'm saying is f prime of pi over 6 is equal to 4/3. In other words, the slope of the tangent line to this curve at pi over 6 is just 4/3. In other words, this line that I drew in green here has a slope of 4/3. It's kind of hard to tell because my x-axis is scaled in terms of pi's. But these axes are not skewed because like pi is like 3, right? 3.14. So pi over 3 is a little bit more than 1. A third of 3.14 is a little bit more than 1. So 1 is, I don't know, somewhere in here roughly speaking. So the distance in the y direction to get to 1 is the same as the distance in the x direction to get to 1. So a diagonal line here, a line that goes through this point 1 over 1, would have a slope of 1, and the line that I originally drew in green is a little bit steeper than this line, which I, for some reason, also drew in green. Therefore, its slope is a little bit more than 1. What I'm saying is this answer kind of checks out. You're like, all right, I guess. Fortunately, I'm done. Like, I don't want to do any more with that problem. No, you're not done. All right, this is just the slope of the tangent line. The question asked about the equation of the tangent line. So while the slope is the hardest part, it's not enough to just figure out the slope. To come up with the equation of the tangent line, probably the easiest way to do it is think y minus y1 equals m times x minus x1. This is what's called point slope form of the equation of a line. Instead of writing m, I can write 4/3 here. I leave the x as an x, and I leave the y as a y. All I got to plug in for is x1 and y1, which represents any point on this line in green. Well, I only have one point specified on this line in green, so this better be the point that I use. It's clear that its x-coordinate is pi over 6, right? The reason we put this dot right here is because we're looking for the line of tangency when x equals pi over 6. So x is definitely pi over 6. What's the y-coordinate, though? What's the height right here? It almost looks like it's 1/2, but I don't think it is. I think it's a little bit more than 1/2. How can we figure out the height of this brown dot? Well, we know that this brown dot is on the graph of f of x equals tangent of x. So all we got to do is take this pi over 6 and put it into this machine and see what comes out. That'll give us the y-coordinate. What I'm saying is just like we had to evaluate f prime of pi over 6, we also have to evaluate f of pi over 6. Now things are getting really confusing, right? Keeping this straight in your head, what you're doing in the different steps. F prime of pi over 6 tells us the slope of this line in green. F of pi over 6 tells us the height of this point right here, which we need to know because we need both the x-coordinate and the y-coordinate to use this point slope form. So what is f of pi over 6? Well, f of x is tangent of x, so f of pi over 6 is the tangent of pi over 6, which begs the question, do you, the student, remember the tangent of pi over 6? You're like, nope, sure don't. Okay, that's fine. You got a couple of options. One option is tangent is always the y-coordinate divided by the x-coordinate. So we could take 1/2 and divide it by the square root of 3 over 2. But I bet at one point in your trig class you didn't do that. I bet you instead memorized some different tangent values. You memorized that this one, corresponding with pi over 4, has a tangent of 1 because it's a diagonal line. And then you remember that there are two other tangent values that you had to have memorized in the first quadrant, this one and this one. And one was the square root of 3 and the other one was the square root of 3 divided by 3. And maybe you were like me and you always confused the two of those, so you had to remember which one was which, and the way you remembered it is you thought about the tangent as the slope of the line. Since it's the y-coordinate over the x-coordinate, it's the slope of this line right here, not to be confused with the slope of this line down here. Oh man, I'm realizing how complicated this is as I say it. Anyways, the slope of this line pictured in green is root 3 over 3 because it's less steep than this line. And my two options, maybe if you remember it that way, are root 3 and root 3 over 3. What I'm trying to say is the tangent of pi over 6 is the square root of 3 divided by 3. So the y-coordinate of this point is the square root of 3 divided by 3. So when I use my point slope form here and I'm plugging in for x1 and y1, in place of x1 I put a pi over 6. And in place of y1, I put root 3 over 3. Holy cow, that got so complicated. Yeah, it sure did. Good news is we're kind of done. I mean, this right here is an equation of this line. And the question said to figure out an equation of this line, so I guess we're done. Might argue, though, that it says the equation, and often implied with the word the equation is that the equation is given in slope-intercept form, not in point-slope form. In other words, kind of implied in the wording of this question is that we should solve this for y. How do you solve this for y? Well, really all you got to do is add root 3 over 3 to both sides, but what people typically do is they first get rid of the parentheses, So they say I got y minus root 3 over 3 is equal to, and then if you take the 4/3 and distribute it through, you got 4/3 x minus 4 pi divided by 18. The 4 times the pi gives me 4 pi, and the 3 times the 6 gives me 18. Now that I don't have parentheses, it's a little bit prettier if I add the root 3 over 3 to the other side, and I get 4/3 x minus 4 pi over 18 plus the square root of 3 over 3. If you've gotten this far, I would be thrilled, and I think that this is more than acceptable as your answer. However, as I often like to do, I want to make the comment that this could be simplified a little bit. I could leave the 4/3 x completely alone, and then I could look at this term, 4 pi over 18. That can be rewritten as 2 pi divided by 9 if I want. Cancel out a 2 from the 4 and the 18, and you're like, yeah, I see that. And then what I'm going to do is, instead of writing root 3 over 3, I'm going to write 3 root 3 over 9. I'm going to multiply the top and the bottom of this fraction by 3. You're like, you could, but why? Well, because that gives me a common denominator here between these last two terms. So I can rewrite things as y equals 4/3 x, maybe plus, and then I can open up some parentheses. I got the negative 2 pi divided by 9 plus 3 root 3 divided by 9, which I can write as negative 2 pi plus 3 root 3 over 9. Yeah, I'm not sure that this is any simpler than what you had here or what you had here. The reason I did this is because the whole purpose of solving for y was to get things into slope-intercept form. And the whole purpose of slope-intercept form is it tells you the slope, this 4/3 that we figured out long, long ago, and the y-intercept. That's this expression that you see right here. So if you're curious about this height right here, how high is the green graph when it crosses the y-axis? I can answer that question for you. It's negative 2 pi plus 3 root 3 divided by 9. Whatever this expression evaluates to is the height of this point. Maybe we were done all the way up here in this purple box, but equivalent to this purple box is this orange box, and I really like this orange box because I think it conveys the most information to the reader about this green line that we're studying in the first place. Lots of potential pitfalls with this problem. Some of them more serious than others. If you don't have your unit circle memorized because you took trig way back in the day, or maybe you took it last term and you still don't have it memorized, you passed that class and you immediately wiped all that information from your brain. That's not that big of a deal. If you struggle to evaluate, say, cosine of pi over 6 or tangent of pi over 6, I'm not super worried about it. I mean, that's calculator work, right? I mean, yeah, if you use a calculator, it'll probably give you a decimal approximation instead of an exact answer, so not quite as good of an answer, but it's not that big of a deal. Another potential pitfall that is a little bit more serious is just keeping this entire process straight. It's kind of like 3 separate problems here, right? I mean, the first problem, we're just figuring out the derivative here, f prime of x. And then our second problem is to evaluate that derivative at pi over 6. Doing that isn't that hard. Like plugging in pi over 6 wasn't that big of a deal. But it's important that you understand why you're plugging in pi over 6. It's important that you make the connection between f prime of pi over 6 and the slope of this tangent line that we're trying to find the equation of to answer this question. That might seem like a subtle distinction, but I think it's kind of important. Speaking of things that are kind of important, if our second question is figuring out the slope here, our third question is figuring out the equation of this tangent line. And if you got lost down in the algebraic simplification down here, I'm not super worried about it, but I would like you to understand how, if you have one point and a slope, you can figure out an equation of a tangent line. This point slope form is something that's fairly important. And when you're trying to use that point slope form, you need to know the y coordinate of this point. The x coordinate is given in the problem, this pi over 6. But to figure out the y coordinate here, this root 3 over 3, that's important. And there's a subtle distinction here too. If you struggle to evaluate the tangent of pi over 6, if you're like, I don't remember that that's root 3 over 3, I don't have my unit circle memorized, it's been too long, that's not a big deal. But if you don't understand how f of pi over 6 tells you the y coordinate of this point that you need for the line, that is a bigger deal. As is often the case in a calculus class, there's so many different moving pieces and you kind of work on problems inside problems and it's so easy to get lost. So make sure you're holding yourself responsible. Go back through here and stare at this not just as some jumble of different colors and kind of ugly math on a page. Go through it really slow and understand what you're doing in each of the different steps. Don't just focus on, can I do this step? Understand, can I, the student, figure out that I should have done this step based upon the prompt given in the problem? I hope I've made that distinction kind of clear. because it's a big challenge of calculus, and I want to make sure you understand where you need to spend your time. That's all I got for this section.